In this example, we're going to be investigating a little bit of network flow. So we are missing a couple arrows here. Let's make sure that these arrows get in here. So overall, we have a total of 700 flowing into the network, and we have a total of 700 flowing out, as we would expect to see that the total flow in matches the total flow out. We also have directions and some unknown flows going between nodes or junctions on this one. So what we're going to do is set up a system of equations, and at each of these nodes or junctions we are going to set up an equation that matches the form flow in is going to be equal to the flow out. Once we set that up, we're going to set it up using an augmented matrix, and we'll call it good from there. We're just worried about the setup. We're not worried about actually solving the associated system. Now I see a total of 4 junctions here, so we're going to be setting up a total of 4 equations. Arbitrarily, let's refer to these as 1, 2, 3, and 4. And once again, we'll be setting up flow in is going to match flow out. So taking a look at junction number 1, the flow in at this node would be x2 and 300. So x2 plus 300. That is going to be equal to what flows out of that junction, which would be x1 plus x3. At junction number 2, what we have flowing into junction number 2 would be simply x1. Flowing out, we have a total of 200 as well as x4. At junction number 3, flowing in to that junction, we have a total of 400. And flowing out of that junction, we have both x2 as well as x5. And finally, at junction number 4, flowing in, looks like we have a lot of things flowing in here. Looks like x3, x4, and x5 are all flowing into the junction. So that's going to be x3 plus x4 plus x5, and that all is going to be equal to 500. Now, in order to set up an augmented matrix for this, first off, it's going to need to be a 4 by 6 augmented matrix, 1 column for each of the variables and 1 column for the augment. We're going to have to do a couple of algebraic manipulations to these equations to make sure that the variables are all on the same side of the equation and that the constants are on the other side. So we can obtain this by saying let's subtract x2 from both sides. This one will need to subtract x4 from both sides. This one's fine as is. We've already separated it appropriately. And then the last one is okay as is as well. So these are the equations that I'm going to use to set up my augmented matrix. Again, looking for a 4 by 6 to represent x1, x2, x3, x4, x5, as well as the augment. When you're setting these up, if you wind up with a lot of zeros, ones, and negative ones, you're probably doing it right. For the first junction, we would set this up as 1, negative 1, 1, 0, 0, with an augment of 300. For the second one, we have 1x1, we have negative 1x4, we have zeros elsewhere, and that will be augmented with 200. For the third equation, already good as is, we'll have a 1 for x2, a 1 for x5, zeros elsewhere, and then 400. And finally, for the fourth junction, we have 1s for x3, x4, and x5, zeros for everything else, augmented with 500. So here's the augmented matrix that describes the flow of the network seen up above.